Okay, I know it's your favorite thing to do, but we are back to using some verifications and proving some identities. And in this time, for the problems that we're looking at in this chapter, is all using the sum and difference or using like double angle when we get there. I think though that you'll find that the verifications that we do this time around are much less intense. There's a lot more direction in where to go and what to start with. So specifically, every problem that we're going to start with today is trying to expand some sort of sum and difference using the identities that we learned in the last couple days, the sum and difference for cosine, sine, and tangent. So, and some of the problems that we look at are like really short. Like it really only takes just a simple expansion and then to cancel a couple things out, and then you're at the place that you need to be. So I will warn you before we get started that it's really easy in the last chapter to drop all the arguments. So instead of writing cosine of theta or sine of x, to just write sine and cosine. It's really important that you don't do that this time because we are looking at two different angles. So we're dealing like with this one, we're dealing with x and y, and those are not the same thing. So the sine of x and the sine of y are not equal to each other because x and y are different angles, like the cosine of or the sine of 30 and the cosine, the sine of 30 and the sine of 60 are not the same thing. So it's important that you leave x and y in your problem and that you don't drop the x and y somewhere. So we need to keep writing it. I know you may develop a habit of dropping that and just writing theta every time or just writing x every time or not writing anything and just writing sine, but we need to actually write those things when we do our verifications this time. So again, the first thing that we're going to do for every one of these verifications basically is apply the identities. Now, I forgot my note sheet at school, so I just want you to follow along on your note sheet, but I'll be doing it on this paper I just wrote out the problems. So again, like we're going to use the sum and difference for sine specifically, so I'm going to write those out at least the way we saw them yesterday. So the sine sum is like the sine of a plus b is the sine of a cosine b plus the cosine of a times the sine of b. And the difference is, oops, sorry, you can't see that. And the difference is the same thing, except we just have a minus here. So it's the sine a cosine b minus cosine a sine b. So what we're going to do is we're going to expand these things out. We're going to treat this as our a angle and our y as our b angle. So when we expand out this first part, we'll have the sine of a, which is x, times the cosine of b, which is y, plus the cosine of a, which is x, times the sine of b, which is y. Then we'll expand this thing out. Now this is a difference identity, which is the same thing, except we just have a minus here. So we're going to expand that out. So we'll have the sine of a, which is x, the cosine of b, which is y, minus the cosine of a, which is x, and the sine of b, which is y. And then we look at our problem, we can see if we can combine some like terms. So I have the cosine of x, cosine of y, I have the sine x, cosine and y. So these are like terms, which is going to combine them into 2, which is conveniently what I want. So let's see if our other terms, those combined. Cosine x, sine y, cosine x, sine y. This is a plus, this is a minus, so these things can cancel out. And we're just left with the 2 sine x, cosine y, which is what we want. So we're all set. That's verified. So again, all we had to do for this one is expand both these things and combine like terms, cancel each other out. We're going to do the same thing for the next one. We're dealing with the sum the sum for sine. Oh crap. Doing the sum for sine, and we'll do the sum for cosine. So I already wrote the sum for sine above, but I'm going to write the sum for cosine down here so we can see that. So that sum was the cosine of a, cosine b, sine a minus sine a, sine b. So again, we'll start here. The only difference for these ones is that we're not dealing with x and y, we're dealing with an actual angle. So at the end, when we actually find the sine of 30, because that'll appear somewhere, we actually have to evaluate. So when we expand out our sine, our sum or difference, or sum for sine, we have the sine of A, which is 30, times the cosine of B, which is x, plus the cosine of A, which is 30, times the sine of B, which is x. And then we'll do the same thing for cosine, the sum. So we'll expand it out using this identity. So we'll have the cosine of A, which is 60. Oops. And the cosine of B, which is x, minus the sine of A, which is 60, and the sine of B, which is x. And we can't like cancel in the same way. Like sine 30 cosine x is nowhere else on our problem. Cosine 30 sine x is also nowhere else. But we do know what the evaluation of the sine of 30 degrees is and the cosine of 30 degrees is. So for those we have to draw a little reference triangle and we can come up with those values. So here's our 30-degree angle. Our sine is going to be 1/2, so 1/2 times the cosine of x. Our cosine value is this side, which is √3/2, times the sine of x, plus a 60-degree reference triangle. Looks like this. We have 60 degrees, this is 1/2, this is √3/2. So our cosine of 60 is 1/2, because it's talking about this x value, times the cosine of x, minus the sine of 60, which is √3/2, times sine x. And now we can look and combine some like terms. So I see 1/2 x, 1/2 x, or sorry, 1/2 cosine x, 1/2 cosine x. That combines into cosine x. 1/2 and 1/2 is one whole. And √3/2 sine x minus √3/2 sine x, those things cancel. So we're left with cosine x, which is what we want. That's our verification. Now, this next one's a little bit different because at first glance, we don't have something that we can expand out. Like we don't have a sum that we see plainly as before, like the sine of 30 plus the sine of x. So that's definitely harder to expand. However, we can write it as a way to expand it. Now, like you might be tempted to start on this side because this side looks a lot more complicated than this side. But one thing to notice is that our arguments don't match. Like this is something with 2x. These are dealing with just x's. So the question is, can I turn this 2x into something with x's? And the answer is yes. Like I can use some sort of sum to turn 2x to deal with only x's. So that's a little bit of a trick. Instead of writing 2x, I'm going to write 2x as x plus x. X plus x is really 2x, so I'm allowed to do that. I'm allowed to break this up and to say it's instead of 2x, instead of 60 degrees, I can write it as 30 and 30, and that's fine. And then I can use our sum formula for tangent. Now our identity for tangent of a sum is tangent A plus tangent B, and then over 1 minus tangent A, tangent B. Now in our case, our A and our B are going to be the same thing because they're both just x. So even though like we have different angles here in our problem, we're just going to replace them both with the tangent of x. So when we expand this, we'll have the tangent of A, which is x, plus the tangent of B, which is, again, x, all over 1 minus the tangent of A, which is x, times the tangent of B, which is x. Then we simplify a little bit. On the top, the tangent of x plus the tangent of x is 2 times the tangent of x. And on the bottom, 1 minus tangent x times tangent x is 1 minus tangent squared of x. And that's what we wanted. Again, that one wasn't like too hard. Most of the ones on the front here are a lot, they're pretty straightforward. You kind of know where to start. This is kind of the one and only trick that we have right now is to rewrite 2x as x and x, and then we can apply some sort of sum. So that's what you're looking for, is to see if we can, if it's not obviously a sum, how can we write it as a sum or a difference to get to a place where we can actually expand it. So on the back, We've got two more. And again, the easiest place to start is to start expanding any sum or difference that you see. So obviously here on the right hand side we have the cosine of x minus y, which is using the difference for cosine. So that's the cosine of A, cosine of B, plus sine A, sine B. So on the top, this is my A value, this is my B value. So I have the cosine of x, which is A, times the cosine of B, which is y, plus the sine of A, which is x, times the sine of B, which is y, all over the cosine of x sine y. Again, you might be tempted at this point to cancel some stuff out, like, oh, we have a cosine x in top and bottom that I can just cancel, and we have a sine y in top and bottom that I can just cancel. But remember, you can't cancel things that are not, that you can't like factor out. Like I can't factor out a cosine x and then cancel it out from here. I can't cancel out a cosine x from every term. So instead, especially because on the left-hand side we want two terms getting added together, and we kind of have that, but right now we have like one whole fraction, is we can now split it up into two fractions. So this is going to be one of our fractions, this cosine x cosine y over cosine x sine y. And our other fraction is going to be this stuff, so the sine x sine y all over cosine x sine y. And now we can cancel some stuff from top and bottom. Like I can cancel out this cosine x from top and bottom, and I'm left with cosine y over sine y. And same thing over here, I can now cancel the sine y from top and bottom, and I'm left with sine x over cosine x. So cosine over sine, that's cotangent, and we're looking at the argument of y. Sine over cosine, that's tangent, and that would be the tangent of x. And that's what we want. Tangent x plus cotangent of y is cotangent of y plus tangent of x, same thing. So again, like pretty straightforward, mostly. Like this one was a lot more complicated because we had to do some of the tricks that we did before, which is like splitting it up into two fractions. But again, I think in general, these verifications are a lot more straightforward. This next one's a little bit trickier because we have a lot of things going on in this problem. One thing that I will mention is to start looking at the arguments first. Like this has a 2x and a 2x and a 2x, but this 4x is different. So if we can somehow change this 4x into something with 2x, then we can try to get to some common place. Now, I don't want to, oh, it's not on the back because I wrote it on a different piece of paper. I don't want to do the same thing that I did over here, which is change that 2x in 2x plus x on this side, because again, like 2t and 2t and 2t are all there. So what I really want to change again is that 4t. Like that's what I should be kind of laser focused on and try to manipulate that a little bit so I can get on the other side of tangent squared. Now again, tangent squared of 2t means I'm looking for the sine squared of 2t over the cosine squared of 2t, which is why I don't really want to change my arguments. So the question is, can we represent 4t as a sum of something with 2t? Sure can. Like this cosine of 4t, instead of writing it as 4t, I can say this is the cosine of 2t plus 2t. And that's the same thing as 4t. So the next step is using the sum for cosine, that identity, which we wrote on the front, but this would be our A and our B, and they're actually the same values. So when we write out our cosine and our sine parts here, when we actually represent it, they'll be the same values, but don't let that confuse you. So we'll have the cosine of A, which is 2t, times the cosine of B, which is 2t, minus the sine of A, which is 2t, times the sine of B, which is 2t. That's at least this first part, the cosine of 2t plus 2t, and then I have plus the sine squared of 2t here at the end. Okay, so let's simplify a little bit. On the top we have the sine squared of 2t. On the bottom, we have cosine times cosine of the same argument, so that means that I can actually put that in a squared. I couldn't do if it was like cosine of x times the cosine of y. That's not the cosine squared of xy, but since these have the same stuff in the parentheses, then I can combine it as the cosine squared of 2t. It has to have the same argument though, so don't let, like up here, don't represent this as cosine squared. That's not an okay thing. Same thing here, sine squared is not an okay thing for that. Since x and y are not the same variables, they're not the same argument inside my function. But these things are, which means that I can represent it like this, cosine squared. Same thing here. These are the same argument, 2t and 2t, so sine squared of 2t, and then plus sine squared of 2t. And you'll see here on the bottom, the sine squared of 2t will cancel out, well, minus and a plus. So we'll be left with sine squared of 2t over cosine squared of 2t, which sine over cosine is tangent, so we can represent that as tangent squared of 2t, which is the verification that we wanted. Again, I think a lot of these problems are a lot shorter, obviously. Like the first ones that we did were just simple expansions. You just have to be careful on your arguments, and then don't write things as like cosine squared when they're actually not. So that's again like watching your arguments, cosine x and cosine y, not the same thing. So you can't represent it as cosine x and cosine y as cosine squared of xy. It's definitely not the same thing. Beckett says hi again. He's here hanging out. Let's see if I can show him. There he is, hanging out on our floor, being a good boy.